Just a very quick presentation. I'm a coder. I like writing code. I'm passionate about code quality. I work. Can you hear me? Yeah. I work in London, mostly in the financial sector, but also other industry. And in this talk, I would like to give some passion that I have about functional programming and how to apply this to CQRS or in general. But so first, how many of you have experience with CQRS event sourcing? Okay. And just how many of you, well, this will come later, but just to know, many of you know Kotlin as a language? Java? I mean, yeah, okay. It's close to Java, so I hope if you have any question, please stop me. I mean, on the slides or stuff like that. Of course, for more general questions, there will be a time at the end. And how many of you have a bad experience with event sourcing or CQRS? Okay, nobody. Probably this is the wrong conference to ask this question. Because in other Java conference, there is also a lot of people with bad experience. But okay. So, what is this? Okay, not the flickering. The flickering is not. So this is in the it's called a gradient in the drawing part, and the idea is the idea that I wanted to introduce is to have this kind of implementation gradient from common pattern to having microservice CQRS. And I mean, all of you are very happy with CQRS, so I shouldn't talk much about this. But a problem that a lot of people had with that is a quite a complicated pattern using this kind of DDD ideas. And you kind of get lost in the implementation. So you have your idea, you have your domain expert, but then it somehow gets lost in the implementation, and you have a system that doesn't work, I suppose. It's very hard to configure, deploy, whatever. So there's a lot of bad experience, I mean, in the generally speaking, the community. So my experience actually is that instead of going to the, I don't know, framework part and just copy-paste the solution from Stack Overflow to any problem, try to implement yourself. Try to implement starting from the basic. And I think there is this kind of gradient. And it's also not, it's even more smooth than these 4 steps. You can have also intermediate steps. So the starting idea is that we have this DDD. So DDD in the sense of we have a domain, a model, which is almost, or at least we know how to, we have intention to write, which is kind of insulated from the technical details of the implementation. So we are DDD, so no, yeah. Ubiquitous language, we are good with aggregates entities. So we have our hexagonal architecture, if you came from Uncle Bob's school. I mean, we have this kind of a nice model. But then, okay, the model, more or less, it works. Or we know how to make it work. Now, the question is, how can I query that model? I mean, how can I interact with that model? And of course, there are several patterns. But one idea is we wanted to capture user intentions. And this is a very powerful idea, which is much older than DDD itself. But the idea is that instead of having I don't know, a model with an API with method 1, method 2, method 3, blah, 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 and then documents that explain how to use method 1 of this with method 2 of that. The idea is that, okay, what people wanted to use our system for, and let's try to capture their people intention. I mean, our user, meaning end user or other developer user, as a command, as an object in technical sense, and then having those that works as API. And whatever is the implementation, because there could be many time implementation, but the idea is that we want to capture the user intention rather than just offer an API that we decide. And so we have this command pattern. And this is the command pattern graph from the famous pattern book, but you can also have a slightly different implementation. The idea is that you have an abstract command and concrete command implementation for all the command that you need. And then, of course, there is someone, a receiver, a command handler, that take the commands and do interesting stuff with that. Which is nice because we can isolate what is the logical domain from the how to interact with the domain, which are. And it's also nice because it kind of allows us to recreate the state, because we say, okay, if we capture all the user commands and we apply the commands, we should probably be in the same position. Of course, it could be different because if the state changes in the meanwhile, I mean, for example, the database is different, I won't be able to replay all the commands. But we have some kind of idea. And or if you start from 0. And this pattern, for example, is started from application like word processor or a graphical tool where you need the undo, because it's kind of easy to have undo if you have a command. It's not easy to implement, but it's easy to have. There are also some drawbacks that bring you to the next state. And the next question is, okay, in our system, we used to have a state. I'm sorry if I'm saying things that you probably already know, but I want to introduce gradually this idea. And so we have the state of our system usually is represented by database or some other persistence. And the idea is that the database is kind of a snapshot of the current state. Everybody is happy with this? And the idea is from event sourcing is, okay, but instead of saving the database every time and changing the database, which is challenging for many reasons, we just register what the difference, the modification that we want to do on the database. And if you think about it, it's the same things that Git does on your source. Git register each difference that you do to the source. And in this way, you have much more information. You have the final state, if you want, but you also have all the history to that state. And so the event sourcing idea is just this. Keep the diff instead of a final snapshot. And this gives us a lot of more power. But, you know, with big power came big responsibilities. And one problem that you may have is a problem of scalability, because since you wanted to register all the difference, that means that every time there is a new command, you have to stop the word, execute the command, because you don't want, I mean, there could be problem of synchronizing. You want all the difference to be in sync. And for example, if you have a system where people, there are some people, a user that insert the data, but 90% of the user just read the data. Yeah, I mean, imagine you are implementing Stack Overflow. I mean, probably 90% of the user of Stack Overflow just browse the data, so just look. And a few people just ask, add a question, add a comment, add an answer. And in that case, if we implement the event state, this request on read kind of clash with the request, with the command to write. So this brings us to the next question. What if we want a different model for the queries? So we want our queries to have more freedom, to be liberated from the constraint that the write poses to the system. And it's true for scalability reason, but it could also be true for data structure reason. So you wanted to see the data in a completely different way from a read point of view than from a write point of view. Or you can have even two different views of the system at the same time. Because we are registering all the difference, we can recreate this view on the fly. And this is the idea of segregating command and query. Now, the schema is just a basic idea. But yeah, basically, I can just show. There's commands, then the command go to the command handler, interact with our model where all the nice things of DDD are, and then it's saved on the event. So these are the events. Then the events got transferred, published to another event handler that updates some data, which is the data that the query interacts with. And so if you want more than one query stack, you can have more than one query stack. For example, in a financial system, you need someone asks you, okay, this is a complex financial instrument. Do me the calculation. Give me how much should I value this product. And you take all the market data, you do all your calculation, then you say the number is 134. And then they ask you 2 minutes later, and you do another calculation, and you say the number is 140. And then they ask you, what's changed in this 5 minutes? Why the number is so different? And the financial system in the bank have to answer this question. What changed the difference between these two things? And for this, to do this, you need a query model that allows us to change the point of time when you ask a question and to reply the same question before and see what's happened, all the events that happen in the meanwhile. And then, for example, you discover that the company publishes dividends, and they are different from what the market forecast. So there is a big difference on the volatility and whatever. But this is the idea that you have much more freedom on the read. And then the final question is, okay, we have all this stuff, but we are in 2018. Single monolithic application is not enough anymore. Everybody, microservice, full scalability, 100% zero downtime, black, green, blue deployment, etc. So we need more machines. And that's also something that goes very well, because the only kind of constraint that you have is that commands must stay in one machine, or at least shared by kind of events. But all the other stuff you can split on as many machines that you want. You can have 10 machines that just do reply to the queries. You can have the buses, dedicated machine, event store, dedicated machine, investor clustered on several machines. All kind of technical solution that you can use. And it kind of go well, and it's also nice because once you implemented your first step, you can just kind of separate the module and say, okay, this module goes on a different microservice. So instead of communicating internally, you just communicate via HTTP. Because it's an architecture that really, really make this transaction very easy. Any question, doubts, disagreements? And so this is just to introduce the idea of this event. I mean, event sources is a different concept from CQRS. I hope it was clear. But they really work very well together. It's really complementary. You can have event sourcing without CQRS if you don't need, for example, for any reason, the double. There are, just to make a real-world example, in the company where I'm working now, there is a small system that uses event sourcing, but it doesn't use a CQRS because the system is so small that it has about a few hundred megabytes of events in total. So why bother? Just load all events in memory, and you can do whatever you want without having to bother with the second read model, which is perfectly fine. That's why I said it's a gradient. You decide how much further you want to do, which are your actually needs. And it's very good for every time there is a complex mutable state. I mean, you have something that you want. Separation of logic. You need auditing. That's one of the big reasons that in financial is quite popular, because people want auditing. They wanted to know who did this for which reason and what exactly happened. And you can, of course, adding auditing to the normal application. I mean, you just audit what's happened. But that is completely left to the goodwill of developers. You forget to put an audit on something critical, because, feature, Friday night, long work hour, whatever. It's definitely possible. And of course, it's very rare that you have a test that really tests if auditing are there. I see that some people. And then you realize that when you need the auditing, you realize the auditing is not there. Instead, with the event sourcing, if there is no auditing, there is no system, so you cannot really forget. And so for anything like editors, orders, trades, whatever, it's quite useful. It's not so useful for example, for batch job or report, stuff like that. I mean, why bother? I mean, you don't really have a complex model. You just need to read some data from a system, translate, and write another system. It's not very useful for stateless calculation, like risk distributed calculation. You take you have all the data, you spend the data in 50 machines, you then aggregate the result. There is no point of. Very high performance, like Exchange or stuff like that. And for very, very trivial code, I mean, for 2 days project, it's probably overkill. Unless your to-do list is really important and you really want. Okay, these are a couple of slides, domain-driven design, and I think that probably the people in this room. But I mean, I think the most important part for domain-driven design is the domain language. You wanted to stay close to the business language. I think for me that is, I mean, you should be in a way that experts in the business, of course, are not able to write code, but they should be kind of able to see your code and see if there is an apparent mistake in that. I mean, your code convention stuff should be something that really helps people to see. And to also trigger a kind of discussion, because, new boys came in the team, boys or girls, start learning stuff, then go to speak with the domain expert, and then they don't have any language in common. What do you call orders? We call invoice. What do you call the transaction? We call unit. I mean, this is kind of common, that you need a senior guy just to translate the two languages. Instead, using DDD means also this kind of discipline, that everybody is on the same language. And then functional programming, and that is the final theme of this speech. How many of you know functional programming? Okay, so it's great. And so the idea of functional programming is functional programming is probably older than object-oriented programming. I mean, depends what you look. But what is the main idea of functional programming is to introduce a kind of a mathematical composition to our code. So write the code in a way that can be transformed and applied like it was a mathematical function. And to do this, you need immutability, pure function, no exception, so all the possible execution path must be taken care of. Transformation, yeah, at the end you have a transformation. And the example in these slides will be in Kotlin, but you can do more or less the same in Java with a bit more verbose, in C#, F# will be even better. So, you know, there are no silver bullets, but I'm really passionate about this combination. Functional programming, event sourcing, and DDD. And this is the meme moment. And by the way, if you have any question later or you want to tweet something, that Ramtop is my Twitter handle. It's not in case you forget. And let's see the protagonist of this story. So how many of you know this? Sorry about doing all these kind of questions, but what is algebraic data type? Okay, so something that not everybody already know. So the idea of algebraic data type is that we are in the functional programming world. So everything is immutable, because in mathematics, everything is immutable. You cannot say, I mean, it's 3 plus 2 means 5. It's not that you take the 2, pick inside the 3, and then you have a 5. And then what it was 3 now is, no. You have always a different things. So everything is immutable. So if everything is immutable, how can I represent something that change its internal state? Something like a system that can be on, off, or waiting, for example. Well, the idea is to create a type aggregating different possible states. And this is how you write in Kotlin. It's I think in the new C# there is something very similar, and of course F# also. So the idea is that basically you can do also without all this help from the language, just using discipline. So you have a seeded class which works more or less like an abstract class that can be extended only in the same file, basically. But it's something, I mean, this is the language help you, but you can do also manually, just. And this class has basically is two subclasses, and we wanted to capture a result of a validation. So we want to capture that I have a type, I do some validation function, apply some validation function to the type, and have a result. And the result can be it's valid or it's not valid. And in case it's valid, we wanted to have an error that tells us why it's not valid. In case is valid, yeah, we want the actual, okay, it's valid, give me the actual value of the result. Now, the kind of tricky part is that when we want the error code, we don't want to have the value in the same class, in the same object. We want an object with only the error. If it's valid, instead, we want an object with only the good value without the error. Normally what you do, you have a both field in a class, and then you choose which to read according to some flag. But using algebraic data type, you can do this. So basically, you put the value directly in the specific class, and then you will open the class when you need it to read. In a kind of sense. I don't know if it makes sense. You really have to try to but keep in mind that this is we have a type that is composed of many types. We will see more example of this. And then we have another concept of functional programming, which is called a fold, which is also called sometimes a reduce or something like that. I mean, folder will be folding paper. I mean, the idea that you have something, and then you have something small. And it's the same from reduce or stuff like that. Oh, sorry. And the idea of the fold is that this is also Kotlin syntax, but you have an initial state, you have an operation that take an initial state and something else, and then you return a new state. I'm just reading basically this. So this is the initial state. This is operation that take the initial state is something else, and then return the new state. And this is something else. In this case, is for example, can be the same. Like if you do, you can do a fold on integer numbers, and you just add them. So you have a list of numbers, and you add all of them. This will be, you start from 0, and then each number you add to the total. At the end, you have the final sum. This is an integer sum. Integer fold, I mean. Yeah, it's a sum, but in this case, we use a fold. On the same thing, the two things can be different. For example, the small bit can be a character, and the initial state can be a string. And you can add a character to the string, maybe with some function that does some modification. But what we want now is, well, we see how we use it actually. I think there is a slide that explains better. But this is just an idea. It's a kind of a recursion function that allow you to compress, to compact, to fold something. A list, an iterable means basically a list. And then, of course, it's command, which is something that makes something else happen in the system. The important part about commands is that command can success or failure, or fail. Some commands can also be not touching the system at all. Command can be just a switch off the system, or give me all the system status, which is not. But the commands that actually go to the model will give you back a result, something like I was other user, and the command can be, I cannot, this username is already taken. Or I cannot because I need more information. Or, of course, can be successful. And then we have events. Events is something that is a difference, as you remember, on the state of the system. So it's not something that can have a success or not success. And in a sense, events name is not a very good name, because people tend to associate events at the beginning, to something that happened outside the system. Like a user did a payment, or something happened, or stuff like that, which is some kind of called external events. But we are not talking about those things. Here, what we call event is an event internal to the system, so changes to the system. So anytime you want to change the current state of the system, or the world system, like adding a new user, change the user information, add an order, anything that will be touching the DB, if you think in the old way, you need an event for that. And then you can see that what we are talking about is we have the state of the system, we add an event, and we have the new state of the system. And this is where you really maybe understand where I'm going to. Because this is exactly the same syntax of the folder operation. You have an initial, you have something that you add, and then you have a new. And then another thing that we have to think about, we have values and entities in these speaking ways. And they are all immutables because we are in functional world. But well, the difference now, since they are both immutable, the difference at the value, we don't really care. I mean, 100 pounds can be a value, and we don't really care if it's this 100 pounds or that 100 pounds. It's 100 pounds on 2 hours of time, whatever is completely independent. Instead, entity is something that, like a user, even if we have another user with the same name, they will still stay different. They don't conflate together. It's something that you keep. But yeah, they are still immutable, and so every time we wanted to, for example, to change a user, I don't know, address, for example, we create a new user, we discard the old user, and we keep the new user. I mean, technically speaking, the entities are still immutable. And then we have the aggregates, where basically, and the aggregates is the kind of unit of the folder that we saw before. And so whatever our events fall to, those are the aggregates of our domain. Because if, let's say, some example, if we have an item events like item created, it will be folding new item at the end, and that will be an aggregate for our system. And then we have the queries, which are like the command, but they don't change, just give a result. They don't change the system. We have the projection, which is this idea of creating a special view of the system using the events, and then create a view which is different from the view that we use to model our writing. So we can have as many views as we want. And very cheaply, we can add the new ones. And then it's an actor, okay, which is another way to organize concurrency, where instead of having locks and share the memory, actor works very well with the functional programming because everything stays immutable, and you have single things that run in their own thread, which are called actors. And they just exchange kind of messages between them. And also, actors are quite useful because they work very easily you can split the actors in different microservices very easily. And then event store, which is, event store usually is the thing where people really got crazy on about discussing details, but it's not that important part. You need an event. You need a way to store your events, which is, you really need one. But it can be anything. It can be Oracle, it can be a file system, it can be a dedicated server, it can be a NoSQL database. Whatever it can be everything in memory. It really depends on your needs. And your needs are quite simple, which is you have if it's a database, you have only one column, one table, basically. And in this table, you need to be able to do query very fast. If it's in memory, of course, that is a given. You just put them up. But then anything else should be able to do this. I mean, any kind of, I saw them implemented in dedicated server, Postgres, Oracle, file system. It's also very good. And so that will be, since my actual implementation was on, I mean, I cannot show you the code, it was also very complicated. I realized that a financial order system is quite similar to a pizzeria order system, where you can order pizza with all the ingredients that you want. So there is the code of this I will show now is available on GitHub. So if you want to look at later or to play a bit. Yeah, this idea was to do a kind of application. It has no persistence and no web front, because the original idea was to do a kind of chatbot, but then was a bit complicated if you will. So, but it is just something that can manage to take orders and get inquiries from a pizza shop, a delivery shop. And yeah, here will be some. Can you read this? This is basically our workflow, something that you can just write on whiteboard on paper, but I really encourage you to do before trying to go on event sourcing. And so you kind of represent your possible state of your system. In this case, we wanted to represent an order by phone of someone that called our shop. And yeah, and you know, there is at the beginning we have an empty order with nothing, which is usually quite useful for functional programming, starting from something from a zero, something with nothing attached. And then we have a new order when someone called, and the order already know who is the user, who's called, for example, the phone number. And then the new order can have an item added, can be canceled, can be address added at the end. So when we have the address and we have the items, we have a ready order, so an order that can be delivered. Then we can say, like, to the user, this is the total, are you okay? He said, yeah, I'm okay. So we'll go on confirm order. So confirm order will go to the pizzaiolo that prepare pizza, put, then delivery man. And then at the end, it will be paid, or for any reason, it cannot be accepted for any reason, it got refused. Is this something similar what you do on event sourcing? Yeah, let me know if there are some. But you need this kind of, you can also do event storming. I mean, it's quite similar to what. The only tricky thing is that you really wanted to represent the state. So each of this order is kind of a different state of the order, which will have a different fields inside the order. So for example, the new order has no address field because only the ready order has the address field. This is the idea that we want to capture. Not having fields that are not related to the state. And we do exactly as we saw before. We create a data class, so a kind of a specific implementation for each of these that they will all inherit from an abstract class. But they are all immutable, so to change something you have to create a new one. And this is how the commands looks like. I mean, this is just we can go very quickly. This is just how Kotlin code looks like, if you have some question. But I think it just to give an idea. So this is something that even if, I mean, if someone is not technical, is a domain person looks at this code, it cannot understand the syntax, but it should understand more or less. It can say, wait a moment, why you don't have a state for X? I mean, and you can say, yeah, because we this on this, or you can say, oh, come on, yeah, you're right, we need maybe this state. Or you can say, why, I don't know, the refuse doesn't have the, I don't know, the name of the person who did the pizza or whatever. And so those was the commands. Then commands got transferred in events, which is actually something that happened. Oh, let me also show you things about commands that I can show you later. Actually, so these are the events. And in this specific case, there is a quite, I mean, commands events are quite related. So a lot of events are just, they have the related command. But also this is only because it's kind of a toy example. If you have a complex domain, you will see that commands and events tends to go far apart. And you should try to have many more events than commands, but many more. Definitely not less, but probably much more. Because at some point in the complex system, you really wanted to fine-grain more exactly what's happened with events. But each new command is quite heavy to implement. So you try not to have too many commands, just to try to catch the user intention. Instead, in the events, you can be more liberal and have a much more event. And these are our queries. And the queries can be, give me all the open order in this moment, or give me the specific order from this phone number, or give me the biggest order up till now, today, because we want to put in the board. Or, yeah, give me all the activate items. So items like menu items, the stuff that's been ordered. So I want to know which kind of pizza they are actually being used, for example. And the one that nobody ordered, we can remove from menu next time. And this is a bit of I mean, this is a bit technical on Kotlin side, but we just created these channels, and then we communicated the channels, basically when there is an event. This is how we transform, we publish the events from the event store to the queries to create these projections. And this is what, the main point. This folder where we can take all the item events or order events, the one that we saw before, and we create an order. So we take all the order events for a given order, ID, from the event store. We fold all together, and we have the current order state. If when we do the query from the event store, we say, get all the events from this ID, but up until yesterday, we had exactly the state that was the order yesterday. This is, okay, useful for financial, not for a pizza shop probably, but the idea is this. You pick up all the events that must be in order, you fold all together, and you get the state. And this is the state up to that event. Any question on this? This is a bit, well. And I mean, I really like Kotlin because the syntax is very clear. The same things in Java, we have much more lines of code, but it's just to show you. And so your entities, basically, they are just a event composable. And they needed to implement basically this function compose, which is starting from, so it starts from a given state, like order, and then all the events that you can apply to order, item added, address added, or cancelled, and then you have a new state. Otherwise, you just ignore the events. So basically, if you remember drawing with a pen drawing that we saw before. From the drawing, you can basically write this class very quickly with all the possible. You have to write all the possible cases, but that's a bit of the point. And yeah, this is this one, just for you to know, is called pattern matching, and you have also, I think, in the new C#, if I remember. But basically, you know that there's another event, but after the one, you can see which exact event it is. So basically, you get and then it allows you to specify all. It's a kind of a case with steroids, switch case. And then you basically you apply the commands in this way. But I wanted to show you the code. So, and then inside the commands, you have the actual logic. In this case, the logic is very, very minimal because, of course, it's a toy example. In the real world, here there will be the call to our model that can have a lot of logic. And sometimes for commands, you need more than one event. Here, I think I'm just using. So basically, for a command, which is execute, I just create one, I get all the ID. So I get one aggregate, and then I can do the stuff. But sometimes I need more than one aggregate, and I need to do more calculation. And then this is how actors work in. So basically, actor just read all the message in the channel. And this is our main application. We have basically, we start all this event store, command, query, and then we process everything. And this is how test looks like. So we create the stuff and then we execute. So want to show some code, but just very quickly. The common pitfalls that I heard of, I mean, better work or listen to other people. The main one is use the query command from command, which is you never, ever do. So you have if you needed to, because probably you already have you need all the users for some reason, and you already have a query for that. So it will be very tempting to use the query model inside your command, but you really shouldn't do it because it really increases a lot of the complexity, and you have to think a lot of possible deadlocks. What you want to do instead is getting all the information from the events. Another thing is that having too many commands, which are both of them, or too few events, which also create a problem because the events, they became too complex. Instead, the events must be very simple. And the other thing is, wrong architecture, having too simplistic or too complex application for your needs. But the most common case is query model from commands. And just for example, one typical something that happened more than once is something like you have a requirement that say you create a new user, but the username cannot be something that is already in the system. So what you do, I mean, how can you be sure that the username is not already in the system? If you have something like this, one thing is that having a query like get me all the user with this name from the query model. But that introduces a kind of loopback because the query model is only eventually consistent, and then instead you can, for stuff like that, you can create a specific event like user created with this username, and then you go on your user event store and you ask, give me the event user created with this username, the new username. And if you find one, you can say, OK, this is already talking. You can. If you don't find, you can say, OK, and you emit the event. So the next person cannot take that name. I mean, this is just a stupid example, but everything that you can do with the query, you can do with the specific events. And this is, yeah. So if you have any, we have almost, sorry, I'm being a bit slow. I want to show a bit of the code. These are my my links. If you are interested, we'll be very happy to keep in the discussion offline, Twitter, blog, GitHub, pull request. So far as technical, I'm happy. I wanted to show you some code. Can you see? No, but okay. I go in presentation mode. Okay, can you read? Yep. So the idea here is that I wanted to add a new command for, let me go to the test, application test. So these are all the tests. And for example, let's take a simple test. Yeah, order to margaritas. So here is my test, create item, blah, blah, blah. And then came the business guy say, come on, I need a new command because I want to know the delivery man. And so after they, what's up? After they confirm the order, yeah, I wanted to have a new event when it has been dispatched. And for the dispatcher, I need to know, of course, the order number, but I also wanted to write down who is the person who did the actual delivery. Because, you know, sometimes we have some problems with the person, so we wanted to know exactly who did the delivery, and then you see for the number of payment that went well, I mean, whatever. So, okay, we need a new, and I can just write the new events and say, okay, dispatch event, and then you say, okay, first there is no dispatch class. So I go to create one. So this is my command, and I can just say, okay, I need a new class, dispatch, where we have the phone number, and then we have the delivery man. And then, okay, and then you can just rerun the test. And we have the new command. But then you say, oh, come on, you forgot to tell me what's happening with this command. Ah, yeah, you're right. And then let's say, so let's say if this is a dispatch, then you execute dispatch. And say, come on, there is no executor for dispatch. Ah, yeah, you're right. Let's do, let's copy paste because we are very professional programmers, so we do copy paste. Dispatch. And then, yeah, I copy pasted the wrong one, which is also one. This is about item. It's a bit easier if I do from the confirm one. Yeah. So we have a dispatch. And then we get the order, which is already same things. We get all the, from the order ID, all the events, and then we fold them, so we have the current order. And then we expect the current, if it's a dispatch, we expect the current order to be already confirmed. And then if it's confirmed, we can say that is a valid, and then that is a new state, which is a dispatch. And then say dispatch, and then we need also the the name of the person, delivery man. And otherwise, we say, okay, the other is not. They say, come on, I don't know this event. Okay, let's write also this event. And again, copy paste. Let's go. So we have the phone number, which is identical, and then we have the delivery man. And you can see that everything, this is the advantage of functional programming. Everything must is really tight. So you cannot easily forget to put, because it doesn't compile. You create your state of application, your graph of states. So if it's not there, it doesn't compile. So now you can run again. Then you say, okay. Of course, now we have a problem that we don't know what to do with the news events that we just emitted. So if it's dispatch, then what do we do? Because this here, sorry, I didn't say. This is the read model, because everything that we did was in the write model, but now also the read model say, come on, there is a new event, I don't know what to do with this event. Okay, we need a new status also in the read models, which is dispatch. And of course, being the read model, we don't really care about immutability or stuff like that. We need something much easier. Yeah, this is dispatch, not dispatch. Also, yeah, usually the command is like a verb, and event is something that happened in the past. Okay, and it went okay, I think, but we also needed to change this one, the pay, to make sure that when we pay only something that has been already dispatched, basically. But and here we can say, okay, instead of pay something that is confirmed, we only pay something that is dispatched. Yeah. Right. We needed to get to the dispatch order. Yeah. Yeah, we almost ran out of time. But you see, what I just tried to, you can see all the code then yourself. And then, of course, yeah, here we needed to implement the dispatched order. But without the information of our stuff. Okay, sorry for the rush final on the code. If any question, now or during the conference, tweet me or anything. I hope you got some good takeaways.